property of waves. The basic way that it works is that when an object which creates a wavelength is in motion, the motion of that object will affect the frequency of the waves it puts out. Here's a scenario. Imagine that each shot fired by this character is a wavelength. They're all leaving the barrel of the gun at the same rate with the same interval between shots. The time between each shot hitting the wall is also the same as the time between each shot being fired. This is an example of the behavior of waves when being emitted from a stationary source at a constant rate. Now let's try adding in motion. As you can see, the bullets are still being fired at the same speed and at the same rate, but the distance between shots is much shorter than before. The way that this works is the distance traveled between each shot being fired is subtracted from the distance between each shot. This is one of the basic principles of the Doppler effect. A similar property is also observable when the source is moving away from the receiving object. Instead, the distance traveled is added to the distance between bullets. This change is caused by the Doppler effect and remains constant across all types of wavelengths, the most easily observable of which is, of course, sound. Have you ever noticed the noise that a passing car makes? When it's coming towards you, it sounds like it's building up somehow. When it's next to you, it's at the apex of that build, but when it gets past you, it sounds as if it's lower pitched than before. Believe it or not, the car is actually making the same noise throughout its entire trip. The only thing that's changing is the frequency of the waves emitted due to the car's motion. When the car is moving towards you, the frequency of the sound waves will be much higher, and therefore it will sound as if it's a higher pitch. At the moment where you're about even with the car, you'll hear the actual noise that it's putting out as it travels, because it's not moving sideways, so no motion will interfere with the frequency of the sound waves emitted by the engine. Finally, when the car has moved past you, the frequency will be perceived as lower than it actually is, so it'll sound as if it's a deeper pitch than it really is. The Doppler effect remains constant over all types of waves, whether that means sound waves, electromagnetic waves, even waves in liquid. It is always in effect. This of course also includes the sine wave. It can be observed in water, where when an object is moving forward, ripples will spread out away from it. Ripples that are in front of it will appear closer together than ripples behind it. An example of the Doppler effect. The Doppler effect is also observable in electromagnetic waves, as it works its way down at a high frequency from gamma rays, X-rays, ultraviolet rays, visible rays, infrared, microwave, and radio waves. Thank you for watching, and I hope you all know what the Doppler effect is now.